When users complain about slow experiences, we need to figure out where the performance bottlenecks are across our microservices. Kloudfuse APM provides quick ways for doing this using spans and traces. Kloudfuse APM has multiple powerful tools to figure out what is wrong and, more importantly, why. As an example, let's go into the front-end service. This view provides you a high-level picture of the requests per second, and multiple P latencies associated with the aggregated requests. It also shows you error rate and AppDex score. To dig deeper, click on the front-end service, which gives you a breakdown of how the requests are coming into the service over time. It also gives you other charts that tell you how the errors are coming in over time, as well as what the response latencies are for the requests that are coming in over that period of time. You can select not just the average latency chart, you can select any of the P star latency charts that we have for you. As an example, let's just look at the P99 latency. So this chart tells us that the P99 latency is at around 23 milliseconds, which means 99% of the requests are being processed within 23 milliseconds, which is good. We also have other breakdowns at the bottom of the screen, which break down the requests by individual components. In this view, we have broken it down by the span name. As you can see, the front end has 4 different span names or endpoints which are being called. The get and the HTTP get endpoints are the ones receiving the most requests. We can even get details about these endpoints by clicking the specific endpoint in the charts that show the breakdowns. All of this data is automatically generated using the span data that is being sent by the service to Kloudfuse. We can also get to the raw spans that are contributing to this data by clicking the Traces tab, looking at all the spans that are associated with this particular service. We also have some toggles here to select whether we want to look at all the spans or just the trace route spans or service entry spans, which are the spans that are the entry point to this service. We could also click the errors only button here, which will only show you the errors coming out of this service. Let's look at an example span. When you click on the span, we get to the trace detail view. A span is usually a part of a trace. We color code the spans depending on which service they are being sent from. So in this case, the teal service is the front-end proxy service, and the purple service is the front end. We also highlight which particular span you're looking at when you click through. At the bottom, we have details of the span. So these are all the labels that were sent, key value pairs that were sent with the span itself. We also have correlating metrics and logs associated with this service. In this view, we are looking at a particular trace and how the trace is propagating across the system. In this case, it has only hit 2 services, the front-end proxy and the front-end service. The flame graph view gives you a breakdown of the time the request has spent in different parts of the call stack. For example, the trace route span has come to the front-end proxy service, which has made a call to the front-end service, and the front-end service has finished in 1.56 milliseconds, and the overall call has finished in 2.01 milliseconds. We also show other metrics associated with this trace. So this trace took 2.01 milliseconds in total, and it falls under the P50 percentile of all the traces that we have seen so far. At the bottom, we also show you the percentiles for the individual spans that make up this trace. So this is a way to navigate to your call stack based on the trace data that has been received by us. We also have other tabs to help you debug further. The waterfall view is mainly to show parent-child relationships between the different spans that we receive. For example, let us go through the root of the trace and walk down from the root towards the other spans in the trace. So you can expand and keep digging deeper. So we got a call on the ingress, which started a client span. That client span called the front-end service. The front-end service started a couple of internal spans and then returned within 1.56 milliseconds. We can also look at all of this information just as span list, which provides you some more options to filter and to aggregate the data that you're seeing. For example, in this case, we can say, I just want to see the HTTP spans associated with the system or any internal spans associated with the system. Let's look at a more involved trace, which consists of multiple spans. This trace has 48 spans. Typically, a span could be the entry point into the service or some internal functions that the service is calling, or a client call to an external service. A span is an independent unit of work that your service is reporting. This particular trace has 48 spans, which means they are all a part of the same request from the user. The spans could be of different types. They could be a HTTP span, database span, or just some internal custom span that your service uses. Let's take a look at some of these examples. To do that effectively, you can go to the span list and filter by different types of spans that are being sent as a part of the trace. If you click on the DB spans, this will show you all the spans that are database calls, in this case, Redis calls that are being sent from the card service. And you can get the associated metrics for each of these spans by clicking on them and looking at all the data that they have sent us, any correlated logs, as well as the overall duration and execution times. Similarly, we can narrow down to HTTP spans or any queuing related spans, which are spans associated with queue processing, like the consumers or producers of queue messages. We can also look at the waterfall view to see the flow of the call starting from the top request and how it flows down your system and makes calls to different parts of the system and other microservices. Let's dig deeper into the spans associated with this trace ID. To do that, you can look at the flame graph. The flame graph represents how the call is broken down with respect to time. So, for example, the root span here is 18.95 milliseconds, and the flame graph shows you how these 18.95 milliseconds are spread across multiple different spans within the system. Another way to visualize this information is by looking at the parent-child relationships between spans. To do that effectively, we have the waterfall view, where you could go through the parent-child relationship in a top-down order. For example, we have the request coming into the front-end service, and then the front-end service is making outbound calls using gRPC to other services. You can look at different levels of the call and how they are being processed across multiple services. As an example, the front-end service is now calling the checkout service, and then the checkout service is doing some internal work, which in this case is preparing some order items and shipping quotes from the cart. The waterfall shows you the parent-child relationships. These are automatically derived using the information in the span, which is mainly the trace ID, the span ID, and the parent span ID. Kloudfuse detects this and automatically stitches the spans together to show them in a neat waterfall and flame graph view. Each of the spans tells us a story. You can use traces and spans to figure out any performance bottlenecks in your system, as well as any errors that are seen by the span itself. We stitch all of this data together and correlate it with metrics and logs to give you a better overall picture of your APM data. So using traces and spans, you can troubleshoot faster and build healthier services. Start tracing today.